This begins Math 098 3.1, and what we're looking at is solving linear equations graphically. So the first thing that we want to point out is that you can still solve these problems algebraically, and you probably remember this from section 1, or chapter 1, excuse me, where you would distribute. As you look at this problem, then you can combine like terms. So we're looking at, negative 10 plus 15 is 5. It's equal to 20. So then you could subtract 5 over. So 5x will equal 15. And as you divide by 5, you'll get x equals 3. But let's talk about what you can do graphically. So I'm going to pull up Desmos. You already knew. To talk about how we can solve this using graphing capabilities. So what you're going to see me do is type both of the equations, and you might be sitting there and saying, what do you mean both of the equations? Well, the left side I'm going to write as a y equals. I'm going to write that down. Y equals. I forgot my plus 15 though. And then the second equation is the right side of the equation, where I'm going to write y equals 20. So what I'm looking for is where the two lines cross. Now I hope you recognize that y equals 20 is a horizontal line, so that means it has to go up to 20, and that's where they cross. So what I'm looking for is the point of intersection, the x value that makes both equations equal to each other. That's why both the y's have to equal 20. And if you're familiar with system of equations with substitutions, that's exactly what you do. You substitute 20 in for this y, and it looks exactly like the equation we talked about. So we're going to explore some more of this without the use of Desmos. So you can see that x equals 3 is the correct answer. So don't be afraid to use your tools to help you out. So what I would do if I were you is I would practice simplifying. So distribute. So what we have is 3x minus 30 plus 5x plus 10 minus 25. Don't even mess with this other equation. I'll tell you what to do shortly. Combine your like terms. And I'm going to write it as a y equation, like y1, if you're familiar with the graphing calculator, which I know some of you are. 3x and 5x put together is 8x. And then combining like terms, negative 30 plus 10 is negative 20, minus 25 is negative 45. Now, in the other equation, let me switch colors. Again, if you're familiar with the calculator, you might write as y2 equals, I'm going to write as negative x plus 9. So as you look at a graph, we're going to go down to negative 45. I'm just going to count by tens. I hope you're okay with that. 10, 20, 30, 40, about halfway down. So right there is 0, negative 45. And it goes up 8 over 1. So as I go to the right one, I'm adding 8 to this value. So that would be negative 37. Up 8 over 1. So again, as I add 1 to the x-coordinate, I'm going to add 8 to this. Negative 29. Continue up. I gotta be careful because clearly that point should have been a little bit further down if I was really counting by tens. So up 8 over 1. Up 8 over 1. Adding 8 to that is negative 13. Up 8 over 1. 5, negative 5. Adding 8 to that puts me at 6. I really hope that this is probably going to be the answer. 6. 5 gets me back to 0, and I need 3 more. Okay, let's look at the other graph. So this is the orange one. I guess I should have color-coded in orange. I can still do that. Whoops. Really wish I did not do that. Alright, my orange color. orange. Someday I will figure out how to use this machine. Whereas if I look at the purple one, it starts up 9. So if I really did count by tens, it would be up 9. Clearly, it's not going to be perfect. And my slope is -1. So it starts at 0, 9, 1, 8, because I have to go down one, right one. So 2, 7, 3, 6, 4, 5. I'm almost there. 5, 4. The next point, as I predicted, is 6, 3. So what we just found there is the point where these two lines cross, and because it's set up as x equals, all I care about is the x value, so x equals 6 is the correct answer. Definitely a lot more work, but at least graphically you understand what's happening when you're solving a problem. And why do we teach you this? So what if we make this problem really, really difficult? You have another way of finding the answer. You can also check your work using this. Well, if I plug in 6 in here, well, 8 times 6 is 48 minus 45. Let me do that. So I think it's important that you realize that you can check your work. Check mark for you. 8 times 6 minus 45 is equal to 3. And then same thing with -1 times 6 plus 9, you will get 3. So this is where the y-coordinate comes into play, is when you plug in the x-coordinate, what do you get? So as I move forward to a word problem, go ahead and pause the video, make sure you understand the word problem. So hopefully you have enough time to really understand the problem. So what you may create an equation. I'm going to use y1 for model 1. So what it tells you is that it costs $5.75. And then they did some math and they figured out that for every hour it runs, it costs them 7 cents. So the key word I tell students is when you see per, that's a rate. When you have a rate, you need to multiply it. It's kind of like slope, right? Slope is a rate. Yeah, and then this is kind of like your y-intercept. It's your starting point. So you start at 575. That costs that much without even plugging it in. Whereas Model 2 is a little bit more expensive up front, but then it only costs 4 cents. And again, you can notice that per in there means your rate. And again, I already read the problem, knew to use x. And so we have the two equations right there. I know the directions, it wasn't there, but I just gave it to you. So if they buy Model 2, that's the y2 equation, how many hours must it run before they save money? Well, you can set it up by creating a graph, and you can create your own graph, or you can go over to Desmos, which is what I'm going to do. So just type into y equals the first equation, 575, 575, excuse me, plus 0.07x and 825, 0.04x. And what you probably noticed, I hope you noticed, and I hope you understand why as well, you can't even see, well, what are the y-intercepts? The y-intercepts of these graphs should have gone all the way up to 800. So we definitely cannot see them yet. And now we finally see them. You can see the more costly one and then the cheaper one. So what we need to do is zoom out until we find that point of intersection, which is all the way over here they need to run this machine for 8,333 hours. 8,333.3 repeating hours. If you round it, I'd be fine if you did. This gives you the exact answer. I'd also be fine if you changed it to 8,333 hours, and 1/3 of an hour would be 20 minutes. Is also the same. So how many days must it run before they save money? Well, what you have to think about is how can you convert hours, the answer you just got, into days? And if you've taken chemistry, you're probably familiar with dimensional analysis, where at least I write it like this. And you want to put your hours in the denominator so they cancel out. Well, how many hours are in one day? Hey, I should have written days there. Thought I hit my eraser. There are 24 hours in a day. So then you can go to that calculator and just take that answer you just got, 8333 point. You can put as many threes in there as you want, and divide by 24. So it would take you 347 days of continuous plug-in. So less than a year. It would only take less than a year. As long as these fridges work for less than a year, you would save money with Model 2. Example 5 is very similar. I'm just going to have you read that on your own, work through it. And this might be a good place to break up my video because I have a couple more examples to go through.